Okay, so I'm going to go back to the dev revolve. Going to reorganize this. So we have the dev blast, we have the dev revolve, advection volumes. For now, it's just leave it. Here on the pop network, I'm going to make sure that what I'm loading is this volume, the volume revolve. As I mentioned before, I'm not going to be using this ramp is not doing anything because we're not using vex expression, so it's just going to be relying on this. The velocity scale for now is going to be staying as is, and let's give this a try. Nothing like just caching out a first version, so we can actually have a look at the whole thing and figure out which point we're at. So I'll use the same elements we typically use for before caching. So I'm going to go to the development blast and grab these two, Control C, Control V, and I think this is ready to go. I'll create a new file cache, labs file cache, in case we need some wedging. I don't think we will. And I'm going to grab the, yeah, why not? The same thing, so at sims cache. And I don't think I'll need a subfolder for this. So this is going to be called revolve. It's fine. It is a simulation. I want it to load from disk when it's done, and I think it's ready to go. So file, save, and I'm gonna save to disk and we'll be right back. Okay, here we are. So let me hit play and see what we have. So a lot of things to address. First, let's visualize this properly, geometry and changes to pixels. And then we do have a few things here. It is working. You can kind of feel it revolve, though we do have some crazy particles being kind of ejecting somewhere. But overall, the effect is there, and it's scattering, and it's looks good. Just some trouble with the advection volume. So to solve this, all you have to do is make sure that on your volume, the advection volume, we're actually going to be applying a PDB smooth. And this will solve everything. Just go into here. If you have a look at this, it's not going to look pretty. Going to lose a lot of detail. So let's bring this down to one iteration. That's enough to clean up those more extreme values on the velocity. And next, what else do we need to fix on this? Okay, maybe reduce the velocity scale a bit. So let's dive inside. Here, let's bring the velocity scale 0.5. And on the birth, let's make sure they kind of die pretty fast. So 1, 0.4. On the source, let's make sure we have a few more, 0.002. It simulates fast enough, I guess. On the pop network, here on the pop advection volumes, something that I haven't mentioned before, but the advection method, you can change it to something else. The single step isn't very accurate, so this will kind of cost us something, but it's not going to be too extreme. Now let's give it another try. Control S to save, and let's save to disk. Okay, let's see how this works. Much better. Much better. So this is a much better effect than what we had before. Okay, I think this is definitely the way to go. The only thing I want to make sure is that the particles we stop emitting after, I don't know, maybe frame 1090 or something, so they don't continue to emit as much. And we can easily do that by animating the, creating a specific control for that. Let's gonna grab this one. And let's create another point triangle. And this one is just going to be a density and im. Gonna actually color it differently so we know that this one is being worked on, and it's going to be just a multiplier for density. So density times equals channel float mult, and we'll start at let's go here. we'll start toning it down from 100, 1070 keyframe 1, and then 1090, 1095 keyframe 0. Okay, let's give this a try. I think it's looking really good. My only issue would be that maybe they're kind of going too far away from the surface. Could be interesting to have them because we already have a bunch of particles around the character without this. So having them stick closer to the character would be an interesting thing to have. We can give that a try. Sorry about that. This is okay, and let's go inside. So how can we do that? Many different ways, as usual, but I'll definitely go with a SOP solver, something we haven't done before, if I remember correctly. So let's use a multiple solver. The pop object is going to go directly here, and the SOP solver is going to go, the pop solver is going to go there. This goes here, and we'll use a SOP solver. Inside the SOP solver, we'll get our surface, object merge. We can get exactly the same surface that we're using here. Let's see, prep robot. I'm gonna grab this one. Either way, it's fine. It's the same geometry. All we want is to kind of connect to it. And we'll use, so let's call this get robot. And we can use array. It's pretty handy. And the only thing we're going to be adjusting here is the method. It should be minimum distance. We want to transform points, but we don't really want to transform them 100%. We don't want them to stick to the surface. That's not what we're going. We just want to kind of push them slightly, very slightly towards the surface. So let's start with 0.005. Remember, this is going to be affecting on each iteration, on each substep. Even if it's just one substep per frame, on each substep, it's going to be kind of pushing it closer to the surface. So let's see if this is a bit too extreme. It might be too extreme, but let's see. So we have this, and I think we're good. Let's give it another cache. Control S to save, and let's save to disk. Now, I think it's fair to say they're definitely sticking more to the surface. We do have some artifacts here, some stepping, which I definitely don't like. Yeah, this is not a very interesting effect to have. To get rid of this, we would need to have some substepping, and that will increase our simulation times for sure. So we can try and, because I think that's being felt on areas that are furthest away from the surface. And we can try and control how much we can establish a limit for the ray to have an effect. So that may help. Other than that, I think the fading out of density is also working. Yeah. So yeah, I think this is a good version of this effect. Just gonna try to fix this. So let's give that a try.